All right, class. Let's tackle U-substitution. It's a little tricky. Okay, so here we go. Oh boy, oh boy, oh boy. All right, U-substitution. This is our second integration method. Now, strangely, there are only two methods of integration that we're going to learn in Calc 1. The inverse power rule and U-substitution. Okay, so this is review of derivatives. Okay, so in this problem, we're taking the derivative with respect to x of this. Now there's a formula inside a formula. So clearly, we have to use the chain rule. So it's kind of like this is an x. So we have 1/6 x to the 6th. That's our outer formula. And our inner formula is 2x squared plus 1. Okay. Let's try it using the chain rule. So the chain rule says, where's my purple sheet that's not purple? It's right here. The chain rule is the derivative of the outer at the inner times the derivative of the inner. The derivative of the outer, 6 times 1/6 is 6/6, which is just 1. Now, we'll leave the inner formula in there, and the derivative goes down. 6 goes down by 1 to a 5. That was the derivative of the outer at the inner. Now let's multiply it by the derivative of the inner. The inner formula is 2x squared plus 1. The derivative of that is 4x. 4x times 1 is 4x. Okay, that was that one. Now we will find the antiderivative of that. Shortly. Okay, let's try this one. The derivative with respect to x of 2x plus 1 cubed is, so 3, leave the inner formula in there. The exponent goes down by 1 to a 2. That's the derivative of the outer at the inner. Now we will multiply it by the derivative of the inner. 2x plus 1. The derivative of 2x is 2. The 1, derivative of 1 is 0. So it's 2. So it's 6 times 2x plus 1 squared. That becomes the problem. Okay. So now we're trying to find the antiderivative of this, which hopefully I get this, because we're going backwards. Okay, let's see here. All right, I'm going to let U equal the inner formula. Now it says this on your purple sheet. So, U-substitution, it says, let U equal the inner formula, find du. Let U equal the inner formula. The inner formula is 2x squared plus 1. Find the derivative of U with respect to x. That's 4x. Now multiply both sides by dx. du equals 4x dx. Compensate if there's a minor drawback. Look, 4x dx is right here, 4x dx. There is no minor drawback. We are going to try to now write this with u's. Okay. So we have the antiderivative. Start with u, 2x squared plus 1. 2x squared plus 1 is u. So right here there's a u. And we have to the 5th. Now, 4x dx we have left. 4x dx we said was du. I have written this information with u's. Now I can find the antiderivative. So it's 1 over the new exponent, u to the new exponent, plus c for good measure. Now, we're not done because u is 2x squared plus 1. So we have 1/6 2x squared plus 1 to the 6th plus c. Now, have I done it? 1/6 2x squared plus 1 to the 6th. Look, 1/6 2x squared plus 1 to the 6th. I have done it. Okay. So what was our process? Our process was let u equal the inner formula. So u equals the inner formula, 2x plus 1. Then it says find du. The derivative of u with respect to x is 2. Multiply both sides by dx. So that cancels. So you want to find du equals 2 dx. Now it says compensate if there's a minor drawback. We wanted to get 6 dx and we have 2 dx. That is a minor drawback. We can multiply both sides by 3 to fix the problem. So now we have 3 du equals 6 dx. Now we are ready to try to write it with u's. Okay, let's try it. So here's the integral. So my tip was start with the u, write that down. So u is 2x plus 1, u squared. Now we have 6 dx to account for, and 6 dx is 3 du. So I need to write down 3 du. So I can put the 3 here, but it would look better in front. So I'll save myself a step by writing the 3 in front, and the du always looks better at the end. So I'll put the du at the end. So I have gotten all this information written here with u's. Now I can take the antiderivative of 3u squared. So it's 3 over the new exponent, 3 over 3, u to the 3rd plus c for good measure. 3 over 3 is 1. Now put whatever u was back in, 2x plus 1. 2x plus 1 to the 3rd plus c. Did I do it? Did I do it? Look, 2x plus 1 to the 3rd, 2x plus 1 to the 3rd is there. And in my problem there was a 0, but there could have been any number that I couldn't figure out. So my c in this problem was a 0. I have done it. Okay, everything is going along nicely. Okay, so let's see if we can continue to figure out this process. Okay, the antiderivative of u with respect to u. So this is just a basic antiderivative problem, inverse power rule, nothing crazy. I will put a 1 u to the first. Ones for emphasis, not necessity. So it's 1 over 2 u squared plus c is my answer. Okay. Here, I don't need U-substitution. I could just distribute and use the inverse power rule. That might be quicker, but I want to practice U-substitution. So I'm not going to worry about that right now. Let's let u equal the inner formula. Now, this formula isn't really inside anything unless maybe I put a first there for emphasis, not necessity. Okay, so let's see if this works as the inner formula. So sort of you're guessing at what the inner formula might be to get it to work. So you're technically maybe not like sure what the inner formula is, but let's just try it. Let's just try this. Okay, so the derivative of u with respect to x is 3x squared. multiply both sides by dx. So du equals 3x squared dx. Oh, 3x squared dx. It works, I think. So if that's the inner formula, this is what du is. Now I think it's going to work. By that, what I mean is I think I can write this antiderivative with u's. That's my goal. Okay, start with the u. X to the third minus 2. It goes right here. U to the first. For emphasis, not necessity. Now, 3x squared dx is du. So I have to put a du there. I can put it there or there. It looks better at the end. Now, what's the antiderivative of u to the first? The antiderivative of u to the first, that's our basic inverse power rule. It's 1/2 u squared plus c. But now in this problem we were done. Here you have to put u back in. So it's x to the third minus 2 squared plus c. And now we're done. So do you see how this was the basic problem? This uses that problem, but adds to it. Now here, there was no minor drawback. So the third problem, there'll be a minor drawback. So let's take a look at that. So let's let u equal the inner formula. X to the third minus 2. The derivative of u with respect to x, it's 3x squared. Multiply both sides by dx, and du is 3x squared dx. What were we hoping to get? Oh, 6x squared. That is a minor drawback. All we need to do to fix this problem is multiply both sides by 2. So now we have 2 du equals 6x squared dx. Now let's try to write it with u's. So this, I'm now trying to write with u's. So we have x to the third minus 2 is u. And if there was an exponent here, that would go here. So this is just to the first. Now, 6x squared dx is 2du. The 2 looks better in front, so I'll put it there. And the du looks better at the end, so I'll put it there. Now, the antiderivative of 2u to the first is 2 over the new exponent, u to the new exponent, plus c for good measure. And 2 over 2 is 1, and u is x to the third minus 2. So here, see the 2 over 2 made it into a 1. Here we have the 1/2, so we got rid of this number right there. Let's try one more. All right. Do you see the inner formula? Let's just try. 5 minus 3x. Let's see if that works. So I guess there are some situations where U-substitution, like it might not work in this problem. But we do not have an inverse quotient rule, so we don't really have a lot of other options. So either U-substitution works, or maybe we can't find the antiderivative. That is possible. Okay, so the antiderivative is, okay, let's try it. The derivative of u with respect to x would be -3, because 5 drops out. The derivative of -3 x to the first, that smudgy thing is just a negative sign. So it's just -3. Multiply both sides by dx, and du equals -3 dx. Were we hoping for a -3 dx? No. We were hoping for a 1 dx, but this is only a, that's correct, minor drawback. We can multiply both sides by -1/3, and we can happily fix the problem. So now we have negative 1/3 du equals negative times a negative is a positive, 3/3 is the same as 1 dx. And we wanted 1 dx, so let's try it. By let's try it, what I mean, we're gonna try writing the problem with u's. I think we're ready. Okay, so write the u first. 5 minus 3x is u. So there's a u right there on the bottom. On the bottom, there's a u. Now, what's 1 dx the same as? 1 dx is the same as negative 1/3 du. I could put the negative 1/3 on top, but that would look goofy. I'll put it in front, negative 1/3. And the du always looks better at the end. So I got it. Now I have to put something on top. I can't put a 0, I'd have to put a 1. Okay, now the antiderivative of 1 over u, if you recall back from the last worksheet, that is our special case. The antiderivative of 1 over u is natural log times negative 1/3 is negative 1/3 natural log of u plus c. So negative 1/3 natural log. Now what was u? U was 5 minus 3x. So we've done it. Okay, U-substitution is tricky until you get the hang of it. None of the math steps were particularly hard, so once you get the hang of the process, U-substitution really isn't that bad, although it's intimidating at first because it's tricky. So give these a shot and we'll see what happens. Good luck.